Hi, welcome to Algebra 2 Common Core. Today we're going to learn and practice a second method for doing polynomial division that's based on our tabular multiplication. We're going to undo that tabular multiplication and use tabular division. So let's start with a review of what tabular multiplication looks like. If I want to multiply 2x plus 5 times x squared plus 5x plus 1, I'm going to set this up so that if I've got a 2 by 3 square for my table, I'm going to put the binomial 2x plus 5 on the left side, and I'm going to put the trinomial x squared plus 5x plus 1 on top, one term for each column. Now recall that we just go ahead and multiply each term in the binomial times each term in the trinomial. So 2x times x squared, that's giving me 2x cubed. 2x times 5x, that's giving me 10x squared. 2x times 1 is 2x. 5 times x squared is 5x squared. 5 times 5x is 25x. And 5 times 1 is 5. Now the way that we read this answer is, of course, we start in the upper left-hand corner because that's going to be our leading term, 2x to the third. Going to the diagonal next, I'm going to add together the like terms that are across this diagonal. 5x squared plus 10x squared, that's giving me plus 15x squared. Go to the next diagonal, so 25x plus 2x, that's giving me plus 27x. And finish it off with the constant that's in the bottom right-hand corner, plus 5. So we found that this method made for a very easy way of keeping track of all of the terms in the multiplication. Well, likewise, that's going to work pretty much the same when I do division. I'm just going to undo that multiplication. So you'll notice that the problem that we're doing now is going to be the same exact problem, but in the division form. So I'm going to start with 2x cubed plus 15x squared plus 27x plus 5. And I'm going to divide it by 2x plus 5. Now, I like to put my divisor over on the left side, but you're going to see some of the examples where the divisor is on the right side as well, so it doesn't matter which side you put it on. I'm going to start with the very first term of our dividend, so 2x to the third, and I'm going to say to myself, what do I have to multiply 2x by, I'll put it here, to get 2x cubed? And of course that's going to be x squared. Now I take that term and I multiply x squared times 2x, yes, that's 2x cubed. Now do the next part of it, x squared times 5, that gives me 5x squared. Now I'm going to go ahead and look at my original dividend and I say, okay, I really needed a 15x squared next. So along this diagonal, I'm going to have that 15x squared. I've already got 5x squared, so the part that I'm missing must be a 10x squared, so that diagonal does add to 15x squared. That allows me to decide what goes up here in this box because I'll say, what does 2x have to multiply by to get 10x squared? That's just going to be our 5x. So now I go ahead and multiply. 5x times 2x is 10x squared. 5x times 5, that's just giving me 25x. Again, I'm going to look along that diagonal and say that these two terms have to be like terms, and they have to add to 27x. So what's missing right here is going to be the 2x. So that along the diagonal, I do have 27x. Decide what I have to multiply 2x by to get 2x, and that's 1. 1 times 2x is 2x. 1 times 5 gives me 5. So when I look inside of the box, I'm getting my original polynomial that I was dividing. On the left side, I've got my 2x plus 5, and where I find the quotient is right up here on top, so the quotient is equal to x squared plus 5x plus 1. Now again, I wanted to do a problem exactly the same problem, doing it by both multiplication and division, so that you can see how the two pieces fit together. In example number 2, we're going to start with a box that's already been created for us. And again, I've labeled some of the pieces. For some of you, that labeling might be very helpful. For others of you, you're not going to need that extra labeling. You'll notice that we're going to start with 2x squared plus x minus 10. So that tells me that in this box right here, I'm going to put the 2x squared. Now in this particular example, the x minus 2 is set up on the right side. You could also have set it up over here, x minus 2 on this side. I just didn't want it to get confused with this labeling of the diagonals. So let's go ahead and say, what do I need to multiply x by to get 2x squared? Well, that of course is going to be 2x. So go ahead and multiply. 2x times x is 2x squared. 2x times negative 2, it doesn't matter which negative 2 I'm looking at, is giving me a negative 4x. And now the diagonal has been labeled here, and we know that this diagonal has to add up to that x that we had in the middle of our original dividend. Now you've got to think carefully here. What do I have to add to negative 4x to get a result of x? That turns out to be a 5x here. So when you look carefully, 5x and negative 4x add to be x. So now that's going to allow me to figure out what I have to multiply this x by to get 5x up here, and that's going to be a 5. Go ahead and multiply. 5 times x is 5x. 5 times negative 2 is negative 10. And that happens to be the term that I wanted on that last corner spot. So that tells me then that the quotient for this is equal to 2x plus 5. So when I do this division, the answer turned out to be 2x plus 5. Now you're probably wondering why we have this second method of doing division when yesterday we just learned how to do long division of polynomials. And the answer is, in Algebra 2 you can actually show your work either way. They won't require you to do one method or the other, but you do have to be pretty proficient in division of polynomials in Algebra 2. So that's why I'm showing two ways. Some people use both, some people focus on one or the other. Today I'd like you to practice with this tabular, even though it's different than what we saw yesterday. So I want you to try this method out, and then after trying both methods, then you can decide which one you like better. Now let's go ahead and look at this next example because it's a little bit more complicated. First of all, we have to create our own table. So when we're creating our own table, I set up a box, but then within my box, I go ahead and leave kind of the number of columns indefinite until I know how many I'm going to need. What I do want to put on here is the correct number of rows. So first of all, when I look at this, I see that I've got an x squared plus 1. Do you notice that we're missing an x term here? And I've got to take that into account when I'm making my rows. So making this, I'm going to say I need a row for x squared. I don't have an x term, but I'm going to leave a row for an x term, and then my bottom is going to be the constant. So on the left side here, I'm going to set this up as x squared, 0 times x, and positive 1. Now let's go ahead and make the first column, where the first term in the first column is going to be x to the 4th. So put the x to the 4th here, and then decide what do I have to multiply x squared by to get x to the 4th? That's going to be x squared. Now go ahead and multiply x squared times each of those terms in that column. So x squared times x squared is x to the fourth. X squared times 0x is just a 0x cubed, and that's going to be important for us to notice. X squared times 1 is going to be x squared. Now, in my next spot here, I see that right now I have an x cubed. If I make the next column, the diagonal, this one right here, is going to have to be my x cubed diagonal. Looking back at my original problem, I see that I need a total of 4x cubed. So if I've already got a 0x cubed, that tells me that this spot has to be a 4x cubed. Now decide what you have to multiply x squared by to get 4x cubed, and that's going to be 4x. Now go ahead and multiply. 4x times x squared is 4x cubed. 4x times 0x is going to be 0x squared. And then 4x times 1 is going to give me 4x. Now I look at the next diagonal, so make your next column. And again, it doesn't matter how wide you make your box, you can keep adding columns on. So the next grouping that I'm going to have is going to be this x squared diagonal. Now notice that this x squared diagonal, because of the size of my box, really has 3 terms. I need to have a total of 3x squared along that diagonal. I've already got an x squared. 0x squared doesn't help me at all, so that tells me that this box has to be a 2x squared. What do I have to multiply x squared by to get 2x squared? That's going to be positive 2. Go ahead and multiply. 2 times x squared is 2x squared. 2 times 0x, that's just going to be 0x. And 2 times 1 gives me a 2. Now let's just check our next diagonal here. I see that I've got a 4x and a 0x. That does add up to my 4x. I also see that I have a 2. That's that 2 right there. So I notice that I'm actually done. Even though it looks like there's extra columns or extra spots in my table I made extra big so that I would have enough room to put everything, but I don't have to use the whole thing. So this tells me that I'm completely done with this division. The other thing that tells me I'm done with the division is that in my answer, in my quotient, I ended up with a constant. So this division is going to give me the answer x squared plus 4x plus 2. And again, you can check this whole table and say, do I have every single term accounted for up here? And the answer is yes. Now in example 4, I'm going to do 2 more examples where I explain them. If you feel like you are ready to go out on your own, then go ahead and do example 4 and the you try it's on your own, and then come back and check with the video. But explaining number 4a, again I see, wow, I've got to have a big table on this one. And again, when I look carefully, I see that what I'm dividing by has an x squared and a 4, but I definitely need to leave room for the x term. So I'm going to say x squared goes here, 0x goes here, and 4 goes down here. I'm going to start with 3x to the 5th in that first spot and say, what has to multiply by x squared to get 3x to the 5th? That's going to be 3x to the 3rd. So you can see that this method works regardless of how big my original polynomial is. 3x to the 3rd times 0x is going to give me a 0x to the 4th. 3x to the 3rd times 4 is going to give me a 12x to the 3rd. Make my next column, go to the diagonal that's going to have my x to the 4th terms. I need a negative 2x to the 4th for my total. I've got 0x to the 4th, so let's put that total of negative 2x to the 4th here so that these two always add together to what I have to start with. What do I have to multiply x squared by to get negative 2x to the 4th? That's going to be negative 2x squared. Go ahead and multiply. So negative 2x squared times x squared is negative 2x to the fourth. Negative 2x squared times 0 is going to be 0x to the third. Negative 2x squared times 4 is negative 8x to the second. Now look at the next diagonal. This is my x cubed diagonal. Make that column. Altogether, I need to have a 6x to the third. I've got a 12x to the third. I've got a 0x to the third. So think about what I need in that spot so that the total is 6x to the third. It's going to be negative 6x to the third. What do I need to multiply x squared by to get negative 6x to the third? That'll be a negative 6x. Negative 6x times x squared is negative 6x to the third. Negative 6x times 0x is 0x squared. Negative 6x times 4 is negative 24x. Make your next column. Here's my x squared diagonal. X squared diagonal has to add to negative 4x squared. I've got negative 8x squared and 0x squared. So think about what has to go in that spot right there so that the total is negative 4x squared. I think it's going to be a positive 4x squared. Go back and check your your diagonal total and make sure you've got what you need there. 4x squared divided by x squared, or what do I have to multiply x squared by to get 4x squared? That's going to be a 4. 4 times x squared is 4x squared. 4 times 0x is 0x. 4 times 4, 16. Now when I look at this whole box then, I see that actually I'm done because this diagonal right here already adds to my negative 24x. Here's that positive 16 that I needed right here. And notice that my last part of my quotient is equal to a constant. So my answer here is going to be 3x to the third minus 2x squared minus 6x plus 4. Let's try one more together. So I'm going to make a box here. Now this time I notice that I'm just dividing by x minus 1. So that means that I only need 2 rows. So I'm starting with x to the fifth, and I've got an x and a minus 1 over here. So I need an x to the fourth to multiply by x to get x to the fifth. X to the fourth times negative 1, that's going to give me a negative x to the fourth. But when I look back in my original problem, I see I don't have any x to the fourth terms up there. So that tells me that this diagonal has to be 0x to the fourth. What do I have to add on? Positive x to the fourth. What do I have to multiply by x to get x to the fourth? X to the third. X to the third times x is x to the fourth. X to the third times negative 1 is negative x to the third. Again, when I check back with my original problem, I see there's no x to the third in my dividend. So this diagonal is going to have to add to 0x to the third. So this next column has to start with an x to the third so that the diagonal is 0x to the third. What do I have to multiply by x to get x to the third? X to the second. X to the second times x is x to the third. X to the second times negative 1 is negative x to the second. Make my next column. This diagonal is going to have to be a 0x squared. Positive x squared adds to negative x squared to get 0. What do I have to multiply x by to get x squared? That's going to be an x. X times x is x squared. X times negative 1, negative x. I'm sure you're seeing a pattern going on here now. Finish it off by saying, oh, my original does not have an x. So I've got to put a positive x here. What times x gives me x? That's going to be 1. 1 times x is x. 1 times negative 1 is negative 1. So looking at my very last corner there, I have made it down to my original dividend constant. So the quotient for this is going to be x to the fourth plus x to the third plus x to the second plus x plus 1. Now, likewise, what this means is that if I take my original divisor, x minus 1, and I multiply by x to the fourth plus x cubed plus x squared plus x plus 1, I should get x to the fifth minus 1. Now I want you to go ahead and try the 2 you-try-its that are listed in your notes, and then come back and check with my solutions, and I'll talk a little bit about both solutions. Hi, welcome back. Let's check your answers for these division problems. For both of these division problems, I'm dividing by a binomial that begins with an x term. So for both of them, we're only going to have 2 rows in our table. For the first example, I see that my quotient turned out to be 4x minus 3. So I started with the 4x squared and said, what do I need to multiply x by? 4x. 4x times x gives me 4x squared. 4x times 1 is 4x. This diagonal has to add up to positive 1x. So that told me to fill in a negative 3x right here. What multiplies to give me negative 3x? So x has to be multiplied by negative 3. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. So my quotient, 4x minus 3. Now again, if you think carefully about what that means, it means that if I take 4x minus 3 and I multiply it by x plus 1, the product is going to be 4x squared plus x minus 3. And you could check that by doing double distribution or using a table. For the second problem, we're dividing by 2x plus 3. I start with my first term, 2x cubed, and say that I need to multiply by x squared to get 2x to the third. X squared times 3 gives me 3x squared. Go ahead and add to get my diagonal. This time the diagonal had to add to negative 1x squared. So I filled this in as a negative 4x squared. I needed to multiply negative 2x times 2x to get negative 4x squared. Negative 2x times 3 gave me negative 6x. Now my total on the diagonal has to be a 2x, so that allowed me to fill in a positive 8x right here. 4 times 2x is 8x. 4 times 3 is 12. Now you'll notice that for all of the examples that we did today, the final number right here always matched with this number. That's not always going to be the case. In tomorrow's video, we're going to see what happens when I end up with a remainder on division. It's really just one little extra step, but in today's work, I've tried to make it so that all of them were divisible evenly. So that told me, for example, in this problem, that 2x plus 3 is a factor of the original polynomial, 2x cubed minus x squared plus 2x plus 12, because I could write x squared minus 2x plus 4 times 2x plus 3 to get that original polynomial, 2x cubed minus x squared plus 2x plus 12. So anytime I can write a multiplication statement to get that polynomial, then I know that both of these polynomials are factors of this original. Thanks very much. We'll continue practicing with both methods of division tomorrow in class. Have a great night, and see you next time.